Yes. Hoping rest few to come now yet. Let's see for what we call Venn diagram, right? See, you can consider any number of sets, like be two or more, okay? Then the relationship between those two sets or more sets can be shown in diagram. Such diagram is called what? Venn diagram. Yes? Okay. The relationship between two or more sets represented by diagram. Such diagram is called what? Venn diagram. So I will take one example. Okay. If U is the universal set, we always show universal set like this with a rectangle box. Why? Because any sets are there, there must be a universal set for those sets. Suppose A is a what set and B is a another set, right? Right. Might be having any elements, might be having relation, might be what they are joining together or not joining together. This simply I have shown a diagram. Universal set always with rectangle, triangle it is shown. Always sets will be shown by what? Circles, and the elements of the particular sets will be written with their respective circles. Suppose set A having 2, 3, 4, right, elements. Again, the set B have got 7, 8, 9 the elements, right? Then you have to write 7, 8, 9 in the circle which is mentioned as B. There only have to write 2, 3, 4. You have taken for set A now. There you have to write in the A circle only 2, 3, 4. And how you have to represent universal set? Always with what? Rectangle. Okay. We'll see more what operations between what the sets also. Let us study the mathematical operations taken between what sets, right? We can have union and we can have what intersection, right? That we'll see. Okay. Now we'll study with what union. Now operations on sets. The first one I'm telling union of sets. If you take, let A and B are two non-empty sets, okay, means having some elements, then union of A and B is the set having the all elements of A and B together. It is denoted as A union B. If we take example, set A having say 1, 5, 7 and B is having 6 and 8, then A union B is nothing but, if you take what similar one, okay, 6, 7. So then A union B will be 1, 6, 5, 7, 8. Okay. Here 7 repeated, but we learned that we never write what repeated elements. It's all known to everybody, right? Everyone now, all you knew that whenever we are finding common elements, we'll write only once, not twice or thrice. Okay? Yes. How many times is repeated? Only one time you'll write it. Okay? Yes. Now this we can show it Venn diagram also. Let's see how we can show. This is universal set. Now A is there here and B is here. A, B have got one common element, that is 7. A covers 7 also, B covers 7 also. See, your element 7 is in the circle A also, in the circle B also. Agree? But A is not having only 7, A is having 1 and 5. Similarly, your B is having not only having 7, it is having even 6, 8. We are telling the union of two sets will be always all the elements of both sets written together in a set. So we have written all the elements of set A and set B written together, right, in a set. So how you will show in Venn diagram that together they are written? We will make them all are having same color, means we'll just shade. See, all these are of same, that we can show. See, whatever part we did like this now, that is A union B. Wherever we have done painting now, coloring now, that all what? A union B. So wherever you have done coloring now, how many elements you are seeing in that? In the colored shaded what? Circles. See? 1, 2, 3, 4, 5. See the answer? 1, 2, 3, 4, 5. How many elements? 5. Here also how many? 5 are there. How easy now? Yes. In diagram also, in wherever we had in coloring, there also all colored elements are 5 only. Even if you are not making diagram, if you see the exact elements punched in the union operation are also 5 only. Yeah. Let us see your union operation on sets. It has got some properties that, let's see the properties. Sure. Let me erase it. Now I'm telling properties of union of sets, right? Here, however you do the union from either set A with the set B, or either from set B towards set A, you will get the same elements. From A to BM filling or from B toward AM filling now, both will get the same answer. So what I'm telling now, the first one, it is commutative. A union B is equal to B union A. You agree? Union means mixing. If are repeated now, only one time we'll write. Either I'm mixing from A to B or from B to A. The mixing is same now, right? Yeah. So what it is commutative. Either from A I am doing the union with what B, or from B with what A I am doing the union operation. No, answer will not change. So what we tell, the union operation is commutative. Let us see whether it is associative or not. Okay. Suppose if I take what three sets, A union B, this I will what make operation with what C also. Whether it's same, let's see. If I take A outside, union, B union C, whether it's same, it means I have got three sets, right? First, I will mix these two sets, okay? Later, I will mix what? The third set. I will see and search in the mixer whether the elements are, how many elements are there, which are those. Okay, I will stop it. I will mix one more time the operation. This time I will keep A set outside. First, I will mix these two. After mixing, I will get one set now. That set I will mix what? A again. There I will see the same thing, nothing change. So, however, whether you are mixing two sets or three sets or four sets, after getting all the mixture now, if you see in the mixture, all elements will be there only. From A also it is there, from B also it is there, from C also. If the same elements are there, we'll write only one time, right? So what you say, whether it is associative, is it associative? Yeah, it is associative. Then it is commutative, and it is associative, right? Let us see one more. Anything is possible or what? If I mix any set with what empty set, what happens? There is one empty box, and there is one more box named as A. It is having some elements. Now I will put all those in that empty box. What you will get? This A box will be dubbed to what? Empty box. The empty box becomes what? A only. Why? Because it is containing all elements of A now. It's true. So here, whenever we are making union operation without empty set, the same set will come back. The same set will be coming back, right? Okay, good. That we call law of identity element. Therefore, pi is the identity element for union. This we call law of identity element. Here pi is the, means the empty set is the identity for union operation. Example, 0 is the what? Identity element for addition. Yes, you can tell additive identity. You can call, nothing wrong. Nothing wrong. Yes, mixing means nothing but it is adding only. But then too, better to have what? The clear words, right? In case of addition, we will use what? 0 as a identity element. Why? Because if you add 0 with any number, the same will come back. Suppose 10 you are adding 0, 10 only comes back. Well, or else you are adding 7 with 0, 7 only comes. Either you are adding 0 with 7 or 7 with 0, answer only 7. So what? 0 is what? Identity element for addition. Similarly for multiplication also there. Likewise, here also we are having what? Identity set, that is empty set. In case of what? Union. Which set you will make union with what? Empty set, the same set will come back. So your null set is called what? Identity of union. Now let us see, if I mix the same set with that same, what will get now? I'm having a set having elements 6 and 7. Okay. And one more set I will take. It's also having 6 and 7. Now I will ask you to mix. But you knew that whenever you're mixing, if the same are there, you'll make it only one time only. You'll get back the same 6, 7. 6, 7 is not, it's set A only, right? So it's true. This is called idempotent law. When you get mixing of two sets, the same set is coming back, then it's called what? Idempotent law. Let us see, if I mix with what? Universal set. Mixing any set with what? Universal set, what happens? I will ask you the question simple, that the river goes and meet the ocean. What happens? Ocean will become ocean only. It never become river, right? No, the ocean never changes. Ocean will be ocean only there, right? Why? Because that is the highest. Many rivers are there in that, right? So what we tell that whenever mixing any set with what? Universal set, this universal set never change. It will be as it is, right? This we call law of universal. What do you call this? This we call law of universal set. This capital U is called what? Universal set. For union, we are not putting any antennas like this, right now. Yes. Please try to see observe what the symbols what we are writing, looking same, but then too it is possible to identify, right? Let us see intersection of sets. We'll go to the second operation. In this we have seen commutative is possible, associative is possible, and if you make what? Empty set, the same set will come back. That we call law of identity. Your empty set is the identity in case of what? Union. Even if you make what? Same sets union, the same set will come back. That we call idempotent law, right now. So then if you mix with what? Universal set, the universal set will come back. That's we call law of universal set. Okay, we'll see intersection. Intersection of sets. If you take what? A and B are two sets, then intersection of A and B is the set having only the common elements of A and B. It is denoted as A intersection B. We will tell this as what? Cap. I know. If I make it reverse, no, that is cup. The symbol is what here? Cap. In case of union, it is cup. I know. What is null? Union null. You only tell what is null with union null. Already we told any two sets are same and you are taking operation, the same set will come back, means null set only come back. Right, nothing wrong. Okay, understanding now? When we are mixing same sets, the same set will come back, the same, whatever you can take, null set or finite set or infinite set of same kind of elements, same set, the same will come back. Let it be. Now we are in the intersection. Intersection, how will right now? You will see whether those two sets are having same elements Those only will pick, and you'll write separately in another set. Such a set which contains common elements of what? Both set A and set B. I'm not telling only two sets. You can take out any number of sets. Suppose A, B, C, three sets I have taken. I will search whether same elements are there in A set, B set, and C set. Those only I will choose. I will write in the form of set. Then I will write A intersection B intersection C is equal to the same common elements. If no elements I have got common, then I will show it as what? Now I have not got any common, so I will write it as null set. Let us see some examples, okay? Let us take some examples. A is the set having 2, 4, 6, 8, 10. But B is another set, it is having 6, 8, 10, 12, right? Then how we will do that A intersection B that we call A cap B. Cap means what? Operation called as what? Intersection. Search for the common. 6 is common, right? 8 is common, good. 10 is also common. Only write what? Common elements of both, right? This is what? Intersection. Right? Very good. Many are giving answer. Already well known. Yes. Now, how you will represent this in what Venn diagram? I will draw first the universal set in the form of what? Rectangle. 6, 8, 10. 6, 8, 10 are common for both circles. It is right now. It's A, it's B. A is having, see, A is having 6, 8, 10. Not only, even B is also having 6, 8, 10. Right? Remaining, here 2, 4 are remaining. Here 12 is remaining. Right? Now, in diagram, you have to show that we have done intersection. The answer is what? 6, 8, 10. So wherever you see the answer, for answer only you have to what? Color it. Color it. Understand now? Therefore, whatever like this I did now, the coloring, that is nothing but what? A intersection B. The shaded part, or we are shading the part where we can see answer. Right? Yeah. Clear? How you have seen the properties for what? Union, the same kind of properties we can see what? Let us verify whether we see same kind of properties or not, right? Okay. Let's see. Properties of what? Intersection. Intersection of sets. First one, whether it is commutative, A intersection B is equal to B intersection A. Do you agree? Means I'm telling A cap B is equal to B cap A. Certainly, think that there are two teams. In the both teams, we can see the common person who can play indoor game also and outdoor game also. Either I am starting from that team or from this team. He is common, he or she is common, right? So it's possible here. It is commutative. Check for associative. A keeping the set outside, intersection is what? B intersection C. Whether is it same as what? A intersection B, bracket complete intersection C. I told you how many sets you wish you can take. Is it possible to find common things? Write them. Whether you start from the set A or you start from the set AB or you start from the set BC, later you're taking what set A, but common elements is common only. They will not be changed. So therefore I'm telling what? Yes. Is it possible? Possible. Therefore I will tell that what? It is associative. Your operation intersection is associative. Let us verify the same what we have verified for what? The union. Is it possible to verify with what? Intersection. Now we'll take null set. If I do intersection with what? Null set, what will be the answer? Very good. Why? Because common is what? Empty. Empty is the common. Right now? How easy to understand. If empty is the common, then what you denote empty? Empty you denote as what? Null set. But in case of what? Universal, A set was coming back. But here in case of what? Intersection, the null set is coming back. Similarly, verify it one more. If I do the same with what? Universal set, what happens? Tell me. Yeah, very good. Because universal set is such a set, it is having the whole, all elements of what? Set A, not only that, other more also. But we are writing only common. Common means A only coming back, right? Therefore, it is A only. These two are possible. So, this we call law of empty and law of universe. So, both together we call what? Law of the null set and law of universal set. But here the fourth one, if I do A intersection A, what you'll get? Think you and you, two common, you alone, I know, right? You only comes back, right? Yeah. Therefore, A only comes back. This we call law of idempotent or idempotent law.
सकाळ कितले एक्सरसाइज केलो काका पण कितले करी
Similarly, there we also see the same in case of what? Union. Now we'll see whether it is possible to distribute union over or intersection over what? Union. Let us see. Okay. I will distribute this intersection over union. Is it possible or not? We have to verify it. Okay. Let us verify it.
कराची के लोग के ना
How will I know?
कराची के लोग
A
बप्पायोरे
intersection
अय्यो गो मचा
B
ना हट 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 पड़ी जीवन
union
थोड़ा
as it is A intersection.
आई तंक विषय वरचा का दिवसा ना
But as per here I'm telling it is possible. How it is possible? We have to verify with an example. Okay. But I knew that it is possible. So I will tell that always intersection is distributive over what? Union.
हाँ भाई मैं चल
Always
लाई रहा हूँ भाई मैं तो बिगी
intersection
बिगी बिगी कर रहा हूँ भाई मैं तो
is
भाई सर
distributive over union. So this we call
बस सिमुलेटर इंडो सीसी
distributive law.
ये तो इंडो सीसी ने इंडोस्मिया
त्याचे मालिका गड मत गोत्ता था
कौन है
बस मला इंडस्ट्री आले कान केलं पडे
कोई
त्याचे गेमा भितरी असतात
कोई रे
Yes.
होत हनुमात मोबाईल
कोई मन
Please don't speak in between.
सोलो
Can you hear me? Is it audible? Okay. Now it is clear that this we have to verify. Simply I have written the law here. Really, your cap is possible to what? Share with what? Union. That we have to verify. Cap means what? Intersection. Right? Whether cap is giving cup of copies to everybody or what? Huh? That we have to verify with what? Some examples. Yeah. We'll go with some other what operations, right? Is it possible to find the difference of sets? Is it possible? Possible. Someone is telling possible. Let's see how it is possible. Now, third operation I'm seeing now, the difference of sets. We'll take what? Difference of sets. Let A and B are non-empty sets. Then the difference, that is A minus B, is the set of all elements of A which are not in B. Example, let's see. A is equal to 1, 2, 3, 4, 5, 6. Okay. And B is equal to 3, 4, 11, 13, 15. Okay. Now I'm asking to find A minus B. So how many of my friends are understanding the definition? Then they can easily write the answer. They can write easily the answer. I'm telling this is nothing but the elements of A. You have to write such elements which are not there in the B. See, 3 is there, 3 is there, 4 is there, 4 is there, right now. Right? I'm telling only you have to write the elements of A, not of B. That too, those should not be in the B. So, but 3 is there, that I will not take. 4 is there, that I will not take. Remaining what? 1, 2, 5, 6. 1, 2, 5, 6 are not in the set B. So what definitions are very much necessary. How perfect you are in definitions, so perfectly you are ready to answer without any what doubt, hesitation. One can answer by the help of our definition only. Yes. Yes. Is it possible for you to show this in Venn diagram? Try now. This what I have done this operation now. Is it possible for you to show on the Venn diagram? Right. Let me take this as A. We have got some common now. 3, 4 are common. This is B. Now 3, 4. If you remember what remains now, 1, 2, 5, 6. Right. Here what remains? 11, 13, 15. Now for answer only how to color. For answer only how to color. See where you can see answer 1, 2, 5, 6. Yes, here you can see. Correct now? For answer part only I have colored. Very good. Then uh, solving problem with what operations and showing the same in the diagram, both side is possible for you. Is it possible? If I give a problem for you there, if I ask you what solve it and represent in Venn diagram, is it possible? Many are giving answer yes, possible. Then we'll go to directly the exercise. Okay, let's see exercise 1.4. Okay, yet few are coming, let them. Similarly, the second one I'm asking. Check it now. There is a set A having the elements ovals, right? There is one more set having only A, B, C. I will write these A union B. A is common only one time you'll write, right now? B, C, E, I, O, U. Count 1, 2, 3, 4, 5, 6, 7. Whether you all got 7 elements in the union, then you are correct. See, every day we'll take attendance now. If you are not giving your attendance, we will get a proof here with names only. Then you'll not be what allowed to what get the exams. Only 27 students came back. Rest yet to come now. Okay. Shall I twist the question now? Little. Okay, I will give what in different. See, third question is, there is a set A having all the elements of X such that X is natural number, is a natural number means n and multiple of 3. Another set is there, set B. It is also having all the elements of X such that X is natural number less than 6. X is a natural number less than 6. Now find the union of these two. Here they have given set builder method form. First you have to write them into roster form, then only it is possible to do the union. Okay. A is equal to multiples of 3. Table 3, 3 ones are 3, 3 twos are 6, 3 threes are 9, 3 twos are 12, right now? So on. It is infinite. Union B. B is what down? A natural number less than 6, 1, 2, 3, 4, 5. Finished. Now A union B. How will write now? 1, 2, 3 is repeated. Only once you have to write. 4, 5, 6, 9, 12. It is not ending. It's not ending. Right? Why? Because union means mixing. While mixing, now you'll see common. If common are there, you will not write 2 times. You'll write only 1 time. Right? Yeah. We'll see one more. There is a set A having elements 1, 2, 3. Another set B is a null set. Find the answer. A union B, nothing but 1, 2, 3 union null set. You get 1, 2, 3. What is 1, 2, 3? Nothing but A only. Who have got A as answer? Means set A only came back, right? Correct.
Okay.
We'll go some other problems.
ಅದಕ್ಕೆ ಬೇಜಾರಿಲ್ಲ. ಹಂಗೆ ಬೇಜಾರಿಲ್ಲ. ಅದಕ್ಕೆ
There is
ಬೇಜಾರಿಲ್ಲ.
a set, set A having the elements A, B, right? And
ನೀವು
B,
ಎಕ್ಸಾಮ್
another
ಅಟೆಂಡ್
set
ಮಾಡ್ತಿಲ್ಲ.
having the elements A, B, C, right? Is A is subset of B? First question. What is A union B?
ಹಂಗ ನಾ ಒಬ್ನೇ ಬರ್ತೆ.
Find it.
ದುಡ್ಡು ಕೊಟ್ಟೆ ಕೊಂಡು ಒಬ್ನೇ. ಓಯ್ ಮಮ್ಮಿ ನೀ ಬರ್ಬೇಡ ಬೇಕಂದ್ಯಾ.
See whether A is a subset of B. The definition does all elements of A must be there in the set B. Then only it is A subset. A, B is there, A, B is there. So what?
ಮಮ್ಮಿಗೆ ಸುಮ್ಮ
First
ಕೂತ್ಕೊಳ್ಳೋಕಲ್ಲ
will answer.
ಎತ್ತಿಕೊಳ್ಳೋಕಿಲ್ಲ.
Yes, A is subset of B. Reason? All elements
ಟೀಚರ್ ಕೇಳಿದ್ರೆ ಬೇರೆ ಬಂದ್ಕೊಂಡೆ
of A
ಪ್ಯಾರೆಂಟ್ ಬಂದ್ರೆ ಕೇಳಿದ್ರೆ
are
ಮಾಡ್ತಿರಲ್ಲೇ.
in B. Second question. What
ಪ್ಯಾರೆಂಟ್ಸ್
is A
ಕೇಳ್ತಾರೆ
union B?
ಟೀಚರ್
A
ಕೇಳ್ತಾರಲ್ಲಿ
union B, how to
ಪ್ಯಾರೆಂಟ್ಸ್
find? A
ಕೇಳಿದ್ರು
is how much? A, B.
ಗೊತ್ತಾಗ್ತದೆ
Union B is how much now? A, B, C.
ಹಾಗೆ
So
ಒಬ್ಳೆ
how to
ಮಾಡಿದ್ದೆ
do?
ಹಿಂಗೆ
Common you write only once.
ಯಾರಿಲ್ಲ.
Remaining also will write. Mixing means common once only write. Extra remaining also you have to write. That is what? Union. So how many have got answer as A, B, C are correct.
ರಿತಿಗ
Let us take one more example. If A, B are two sets such that A is subset of B. A is subset of B. They are already given. Right? Then what is A union B? They're asking what is A union B? Already such question we solved it. See, A union B did here now. B is the bigger set, so it is nothing but B only we got here, right? Now, if A is subset of B and you're finding A union B, you get what answer as what? If A is subset of B, then A union B is always set. The bigger set only comes. Very good. B, 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 B. 3 times she answered. Okay. Again, one more. I will give out around 4 sets for you now. I will ask some operation. Ready? What are those four sets? If there is a set A, B, C, and D, okay? A having 1, 2, 3, 4 elements, but B is having 3, 4, 5, 6, and D 5, 6, 7, 8, C 5, 6, 7, 8, and D 7, 8, 9, 10. Okay. Now the question is what? Now you have to find these all. Okay. A union B, A union C, B union C, again B union D. If possible, find the union of three sets. It is not impossible, it's 100% possible. You have to find it. A union B union D, I'm asking. Last one. B with C with D. Okay, take this as a homework. Okay, quite easy. Or else take it as a classwork only. Now only you can finish. Just watch out. A union B. 1, 2, 3, 4, 3, 4, 5, 6. 3, 4 common. Then 1, 2, 5, 6 is the answer for this. A union C. A is here, C is here now. Here 1, 2, 3, 4, 5, 6, 7, 8. No common elements are there. Then we had to write 1, 2, 3, 4, 5, 6, 7, 8 only for this. B union C. B is having 3, 4, 5, 6. And this having what? C 5, 6, 7. Only 5, 6 is common. Once 3, 4, 5, 6, 7, 8. Only one time you have to write. Union, I'm telling you. Right now. Here also A union B. 1, 2, 3, 4, 3, 4. 3, 4 one time. 1, 2, 3, 4, 5, 6 only to write here. If you come to B union D, B is 3, 4, 5, 6. D 7, 8, 9, 10. No common. Then write 3, 4, 5, 6, 7, 8, 9, 10 only. Similarly, A union B first you have to find. Find first these two. You'll get an answer now. That answer you have to make union with what? C. Right? This way you can find all these answers. Okay, see you all. We'll see you in the next class. Till then, bye.